Okay, we're talking about less than 10.8 areas and volumes of similar solids. Find the relationship between the ratios of areas and volumes. This is SOL G13 and G14. We want to start by reviewing what similar figures are. Similar figures have corresponding parts that are proportional. So 3/9, which is also 1/3. It has a scale factor or similarity ratio of 1:3. In other words, the figure on the triangle on the right is 3 times as big as the one on the left. The perimeter ratio is the exact same. They are equal. Okay, so similarity ratio is 1/3. The perimeter ratio is also 1/3. Now, we'll go down here. Find the value of x. What would x be? Well, the similarity ratio is 1/3. We set that up to the other part. 9 over... Oh, made a mistake already. Let's do that again. So if the similarity ratio is 1:3, 3 and 9, I'm going to use the parts right from the triangle. 3/9 is equal to x over 21. When I solve that, I get 9x equals 63, and then x is 7. So the value of x is 7. Now, to find the area of these triangles, remember it's length times width divided by 2, or base times height divided by 2. So 3 times 7 divided by 2. That's 21 divided by 2 is 10.5. When we do the same thing over here, 9 times 21 is 189 divided by 2 is 94.5. Now, let's look at the ratio that makes as well. 10.5 divided by 94.5. If I go to my calculator and hit MathFrac, I find out that that equals 1/9. Now, how does 1/9 relate to the ratio that we had earlier? 1/3. Well, we should be able to see that 1 times 1 is 1, and 3 times 3 is 9. So the area ratio is squaring the similarity ratio. We just square it, and we make it the same. So, solids that have the same shape and corresponding sides are proportional. Again, we have to determine if they are similar. So we might say 4:6. And we want to see, is that the same thing as 6:9, which is the same thing as 14:21. Well, all those fractions simplify to 2/3. So they are equal. As the decimal, it would be 0.6 repeat. So show they are similar. Well, that's what we just did up above. Said, are these two similar? Well, let's look at these two shapes. Okay, we're going to say is 12:9. Is that the same thing as 6:5? Okay, well, if we cross multiply and look at that, we get 60 is to 54. Is that equal? Well, no, it is not equal. Therefore, they are not similar. Therefore, not similar. Okay, that's a little bit of review. We've talked about that before. Now, if a similarity ratio is A to B, then their corresponding area ratio is A squared to B squared. And the volume ratio then is A cubed to B cubed. Okay, well, let's go ahead and look at a couple problems. The radius of a small cone is 12. The radius of a large cone is 14. 12 to 14. So our initial ratio is 12 to 14, and that simplifies the 6 to 7. I suggest you do that simplification. It helps us work with smaller numbers. that implies then the area ratio is 36 to 49. And we'll use that to solve our problem. Find the surface area of the large cone if the small cone's surface area is 42. The small cone's surface area is 42. So we put 42 up top. That's where our small cone is. X on the bottom. And we cross multiply. And we then solve this. Now, for sake of time, I'm going to leave all the mathematics up to you. So 49 times 42 divided by 36 would be our answer. So we'll come down to the next example as well. Okay, find the volume of the small cone if the large cone's volume is 1372. We've got to find the volume. Again, we go back to our original similarity ratio, 6 over to 7. The volume ratio then cubes those numbers. So 6 cubed over 7 cubed. Well, we're just going to leave those numbers right now. You can put them in your calculator at any point and figure out what that is. But they're going to be equal to, it said, the relationship. Well, I had to make a phone call there, so we'll continue. Is this going to be equal to the large cone's volume, as the cone on the bottom is 1372? Well, over x, we're trying to find x. Well, in solving that, we just take 1372 times 6 cubed is equal to 7 cubed times x. Therefore, to get x by itself, we're going to divide by 7 cubed, and we would find our answer. That is an equal sign, for those that are wondering. So we're going to divide those and get our answer. Let's go ahead and look at a couple more examples before you get started on your IXL assignment. Find the similarity ratio of two cubes with volumes of 729 and 1331. Well, those are volume ratios. And we know that the similarity ratio has a cube relationship. Therefore, we're going backwards. Okay, that implies that we want the cube root of 729 divided by the cube root of 1331. Now, you want to keep your answers as fractions. The cube root is found on your calculator by hitting the math button, and then it is number 4. So I put the cube root is 729, and that is 9. And then I do the same with the next part. And that's 11. So that is the similarity ratio, 9 over 11. Don't forget that is also the perimeter ratio as well, since this is one-dimensional. Find the similarity ratio of two similar prisms with surface areas of 144 and 324. 144 over 324. So this time area ratio is squaring, so we got to take the square root. Square root of 144, well, I know that's 12. The square root of 324. I think that's 18, but I will check real quick. 324 is 18, and 12 over 18 can be simplified. We divide everything by 3. You get 4 over 6. Guess we could have done a little more, divided by 2. You get 2 over 3. And that would be our final answer there. Similarity ratio. And the rest of it is an assignment on the back side of your worksheet. That's due, or you're to work that after you do the IXL assignment. 2 through 16 even, number 17, and 44 through 46. So you may need to add that to the paper that you have.